Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now I am going to solve this particular problem. In this problem it is said that specify the magnitude and coordinate direction angles alpha 1, beta 1 and gamma 1 of F1 so that the resultant of the three forces acting on the bracket is this thing. This is Fr minus 350k. So the resultant is only acting in the negative z direction, right? And it is said that note that F3 lies in the xy plane. So this F3 is lying in the xy plane. So this means that F3z component is 0, right? So first I will write the Cartesian vectors of F1, F2 and F3. So if I write F1 vector, so F1 vector in terms of coordinate direction angles, right? Since alpha 1, beta 1 and gamma 1 are the coordinate direction angles, and we are required to find the magnitude of F1 and this alpha 1, beta 1 and gamma 1. So we can write that F1x will be F1 cos of alpha 1 I plus F1 cos of beta 1 j plus F1 cos of gamma 1 k, right? Similarly, we can write F2 vector. So as we can see that F2 vector is only acting in the negative y direction, right? So its x component is 0, right? And its k component is 0, right? And its y component is acting in the negative y direction, so we will write minus, and F2y magnitude is 200, right? Since the whole F2 force is acting in the y direction, right? So this is minus 200 j. And similarly F3, right? So F3 has two components. It has one component which is acting in the positive y direction. This is the cos component, and it has one another component which is acting in the negative x direction, right? So this is F3x, and this component is F3y, right? So F3x is the sine component if we consider this triangle. So this is 400 sine of 30, and since the angle is made with the F3y, so this is the cos component. So this is 400 cos of 30 degrees, right? So I can write that F3x is 400 sine of 30. So 400 sine of 30 I. This is acting in the negative y direction, so I will write minus, right? And similarly F3y is acting in the positive j direction, so I will write plus. This is 400 cos of 30 j, and its k component is 0, right? Now if I add F1 plus F2 plus F3, so they must give us the resultant Cartesian vector. And in the problem statement it is said that Fr, let me write that this is Fr. So Fr vector is equal to minus 350k, right? So let me write that this is minus 350k, and the j component is 0, and the k, the x component, the I component is 0, right? So this is 0i plus 0j minus 350k, right? So now if I add F1x plus F2x plus F3x, so this must be equal to 0. So I can write that F1 cos of alpha 1 plus 0 minus this 400 sine of 30, this must be equal to 0. So I can write that F1 cos of alpha 1 is equal to 400 sine of 30. Similarly, if we add F1y plus F2y plus F3y, so this must also be equal to 0. So I can write that, first let me simplify this, right? So F1 cos of alpha is 400 sine of 30. So this is equal to 200, right? So we can write that this is equal to F1 cos of alpha 1 is equal to 200 pounds, right? So let's say this is my equation 1, right? Similarly, if I add F1 cos of beta 1 minus 200, this thing plus this, right? So this is plus 400 cos of 30 degrees. So this must be equal to 0, right? Since this Ry, the Fry component is 0, right? So from this we can write that F1 cos of beta 1 equals to So this is equal to minus 146.41. So f1 cos of beta 1 equals to minus 146.41 newtons, pounds. So this is equation 2. Similarly, if I add this f1 cos of gamma 1, so f1 cos of gamma 1 is directly, I can write that f1 cos of gamma 1 plus 0 plus 0. So this is equal to minus 350 pounds, right? So let's say this is our equation 3, right? So as we know that in terms of the coordinate direction angle, f1 cos of gamma 1, this is f1x. This is the component of f1 in the x direction. Similarly, this is f1y, and similarly this is f1z, right? So using this f1x, f1y and f1z, we can find f1 magnitude which is required. So f1 magnitude will be equal to this 200 square f1x square plus this square and plus this square, right? So this is 350 square, and we will take the square root. So this will give us the f1 magnitude. So f1 magnitude is, we can say that it is approximately 429. So f1 magnitude is 429 pounds. And similarly, we can find alpha 1, beta 1 and gamma 1 using this 1, 2 and 3 equations. So from equation 1, we can write that cos of alpha 1 will be equal to 200 divided by 429. And if we take cos inverse, then this will be equal to alpha 1, right? So alpha 1 is cos inverse 200 divided by 429, right? So alpha 1 is 62.21 degrees. Similarly, using equation 2, from equation 2 we can write that beta 1 is cos inverse minus 146.41 divided by this f1, so which is 429. So this is 109.95. So we can say that this is approximately 110 degrees. And similarly, using this equation 3, we can find gamma 1. So from that equation 3, gamma 1 will be equal to cos inverse minus 350 divided by 429, right? So this will give us gamma 1, right? So gamma 1 is minus 350. So this is 144.67, so it is approximately 145. So gamma 1 is 145 degrees, right? So f1 magnitude is 429, gamma 1 is 62.21, beta 1 is 110 degrees, and gamma 1 is 145 degrees. So this is the solution of this particular problem.